Hi, good day everyone. So today we'll be doing Jan 2019, number 7, paper 2. So these questions are typically, number 7 are typically our sequence questions. Let's read question. A sequence of figures is made up from joining polygons with sides of each unit length. The first 3 figures in the sequence are shown below. So figure 1 would have 1 house looking figure, figure 2 has 2 house looking figures, figure 3 has 3 house looking figures. So figure 4 would obviously be, I'm just drawing this by hand, so excuse me. Right, my red is to just show the dotted, right? It's supposed to have 1, 2, and 3. Oh no, it does not have a line going across like that. Right, then it have the houses, the little peaks. Right, and this would be figure 4. So you have 4 house-shaped figures, and you're supposed to have 3 dotted lines, right? And that's how it's supposed to look. Right, part B, study the pattern of the numbers in each row of the table below. Each row relates to one of the figures in the sequence on page 23. Some rows have not been included in the table. Complete the row number 1, 2, and 3. Right? Alright, so when you see a question like this, typically, I would say always find the formulas first and then work backwards. Right? So we know that if you look for the number of outer lines in the unit length, I would say you look at the first values, right? The second values, and your third values, right? That is, your first values would be, you're seeing 1, 2, and then 3. And then you compare it with your figure number. You want to see how do they, you would look at the relationship between your figure number and your first values, right? If we look at the figure number and your first set of values, you can actually see that your first value is actually your figure number, right? Your second values is 2, 2, 2. So you can say, well, there's a constant of 2. And then your third values was 3, 4, 6. And we look at the figure number and say, what is the relationship between your figure number and your last set of values? Or what you could have done, and this is what I would have done, is you could have used the formula, because this is actually a sequence, right? You could have said AN is equal to A1 plus N minus 1 by D, where A1 is equal to your formula, your first value, sorry, right? D is your difference, which is 2, right? And we'll just say N is equal to N, right? That means AN is equals to 2 plus, open bracket, N minus 1 by 2, right? That is AN is equals to 2 plus 2 by N is 2N, and 2 by minus 1 is minus 2. These two will cancel out each other, so you see AN is equals to 2N. If you could not have seen that, I am actually multiplying my figure number by 2 to get these last set of values. This is the formula that you would have done. So if I put in it in, the first value is N, which is my figure number, plus 2 plus 2N. Now, when you see N plus 2 plus 2N, right, we group like terms. You're going to say N plus 2N plus 2. N plus 2N is 3N. So it's going to be 3N plus 2. So that will be your answer for the formula for N. Now, once you find this out, it's easy to do these other two. Let's look at the parameter now, right? I'll just go to the side here. Your parameter, your sequence is 5, and then 8, and then 11. Let's see if there's a common difference. The difference between 5 and 8 is 3. The difference between 8 and 11 is also 3. right? So we know there's a difference of 3. Your first value, which is A1, is equal to 5. You put it in the formula, AN is equal to A1 plus, open bracket, N minus 1 by D. So we want the N, we're solving for your nth value, so that means N is equal to N as well. We put in these values in this formula. So wherever you see N, you're leaving it as N. So AN is equals to A1, that is 5, plus, open bracket, N minus 1 by D, which is 3. So AN would be equals to 5, and you're going to use your laws of distribution. That's 3 by N is 3N, and 3 by minus 1 is minus 3. So it's going to be plus 3N minus 3. So AN is going to be 3N plus 5 minus 3. So AN is going to be 3N plus 2. And that would be your answer for your formula here, 3N plus 2. Right? So once you find these formulas, the other two are very easy to solve. Now, let's do part 1 first, because part 1 is easy. If we equate n and 6, you can see n is equal to 6. So when n is equal to 6, you put it in this formula. That's 3 by 6 plus 2, that's 18, plus 2 is 20. So my value for an outer number of outer lines and unit length is 20. This one here will be 3n plus 2. That would be, I am incorrect for adding this up. No, they want it in the form. So this is not supposed to be the answer. The answer would have been 6 plus 2 plus 12. Right? Okay, and then this one, right, now you're going to put it in the formula. That's 3n plus 2. That would be, it's just you're adding up these, right? That's 3 by n, which is 8 threes are 16. I mean 8 threes. 8, 6 threes are 18. 18 plus 2 is equals to 20. So your answer here would be 20. So the parameter is actually the value of your parameter. And this one, you have to put it in the order they have it here. So it would have been the figure number plus 2 by a figure number, which is 12. Now, part 2 here, they said, well, I want to know what are these two when my parameter is 65. That means we are solving for n. So 3n plus 2 is equal to 65. Now, guys, before I continue, do not reduce it to 3n plus 2. Put n plus 2 plus 2n, because that is the order in which they have it here, right? Yeah, anyway, right, so 3n plus 2 is equals to 65. So we're going to make n the subject, and we're going to carry across. Again, if you're doing BODMAS tells us the order in which we would do our operation. We're going backwards from BODMAS, right? So there's no subtraction, but there is addition. So remember, we're going backwards, so we're going to carry across addition first. If you carry across add 2, it's going to be 3n is equals to 65. Opposite of plus is minus, minus 2. So 3n is equal to 63, right? There is multiplication. That is the relationship between 3 and n is multiplication. So you're going to carry across, multiply by 3. So n would be 63 divided by 3. If you carry across, multiply by 3, it'll turn to divide. So n is equals to 13. So your answer here is 13. Now that we found out that n is equals to 13, we can put it in this form. That is 13 is the first value, plus 2 by 13 is 26. So this is going to be the form it's supposed to be in, and that is how you would do this question. All right, so if we look at part C, show that no figure can have a parameter of 100 units. So they're telling you that 3n plus 2 is not equal to 100. It cannot be equal to 100. So we have to show that. So we're going to make n the subject. Now, n could only be, what you call this thing? N could only be whole numbers. Right. So let us make any subject to see what is your figure number. You carry across, again, we're going to do opposite of BODMAS. So you carry across plus first, so that's 3n is equals to 100 minus 2. So 3n is equals to 98. You carry across, multiply by 3, that's divide by 3. So n is equals to 98 divided by 3, which is 32 and 2/3. Now, n needs to be a whole number. Because if we look at it, your figure numbers here are whole numbers, right? You cannot have 32 and 2/3 of an thing. So n needs to be a whole number, and we found n to be 32 and 2/3. Therefore, the parameter being equal to 100 does not exist. Right, so all you need to say is n needs to be a whole number, and we found out n to be 32 and 2/3, which is not a whole number. So therefore, p, which the parameter being 100, does not exist. And that is how you would do now January 2019.